Do you ever get sick and tired of how frequently things break, and even things that cost a decent amount of money in this day and age? We all accept that a lot of electronics is made in Asia and other countries where the cost of manufacturing is a lot less. But we still want to buy good quality products, and when there's a name brand attached to it, like Logitech, you kind of expect it to last a long time. This is a good example. I really like this mouse. It's a touch wheel mouse. I've had it. It's a wireless. It's got a middle button. But the problem is the buttons are intermittent. This one in particular, the left click, it sounds fine right now. Here it is. But it died, and I got curious and thinking, well, I used to be a bench electronics technician repairing electronic gear in the 90s. That's how I started my career in electronics, and I thought, I bet I could fix it. I bet I could find, the only challenge is finding the actual switches to replace with. And you know what? I took a look on AliExpress and I found them, and they've arrived. So what we're going to need to do this today, we're going to need a decent soldering iron, a small set of screwdrivers to get this apart, and a solder sucker, and I'll show you what to do. So down here on the mouse cam, I'm going to use my jeweler's screwdriver set. Pull the battery compartment, get the batteries out. And these typically only have one or two screws holding things together. And here you can see it. There's the little storage spot for the receiver, for the Logitech unifying receiver there. Take that out. Have a look in there. You can see it really clearly in the light. There's one screw right there, so I'm going to take that one out. You've got to be careful with these little plastic screws because they can eat out the plastic pretty easily. They're only really made to go one time. So we're going to, with just one screw there, one tiny screw, we're going to put that aside, keep it safe. And here the whole assembly, the whole shell comes apart like a clamshell. We just gently pry it forward. Comes off. There's the inside of the cover. You can see all the plastic springs and actuators are in good shape. And the mouse on the inside is the antenna board that gives the RF connection to the receiver. And these are the main micro switches, or tactile. These are technically called micro switches. That's the type of switch they are. And there's a tiny little, if you can see it in there, that silver dot square, that's the switch for the middle button. It has a plastic lever that comes over and pushes down on that. That one's okay. It's these ones that need replacing. And if you look at those, they say D2FC-F-7N is the part number from the manufacturer. I'll do a quick look up on these, just a Google, or use Octopart to search for the component, and pretty soon discover that these are made by Omron, and they're pretty common. I look on AliExpress, and I was able to find replacement switches in packs of 10. So I've got my pack of 10 arrived just recently. We can see, looking at these switches, do a quick comparison. The printing's different, the ink is different on them, but they are the same size. So I assume this is actually an aftermarket clone of the original, but maybe they just changed the printing on the factory machines. Who knows? As long as it works, I don't care. So the next thing we need to do, we're going to have to desolder the old switches and solder in these new ones, and then trim the legs off them after soldering. So the next thing we need to do is get all the PCB assemblies out of this mouse. So we can see there's, again, one sort of main screw there. There's a couple of screws for the battery assembly that also clamp down on top of the printed circuit board. So I'm going to have to take a few of these things out. Let's start with the battery assembly. Two screws there. Sometimes you have to look pretty closely. And that kind of comes loose. One has to be careful. There's a ribbon. There's a ribbon cable in there, and another wire that probably goes to the other end of the batteries, and another tiny black wire right here. Don't really want to break any of these, so I'm going to leave them attached, but just allow this to be loose, and then undo that one screw holding the rest of the PCB down, and then hopefully there's no others. It could be there is actually another one hiding that was under the battery compartment there, under that cable. So I'm going to loosen that one as well. It's important to have a tidy bench or work area to do this, because we don't want these screws to go flying. And there's just one more that's kind of hard to get to. If I tip that up, I'll get to it. One more back here. You can see that there. And then that whole thing. And I've got to pry this. This has to pop out there. So the wheel's out, wheel assembly's out. I'll leave that there so you can see it. And that whole printed circuit board assembly comes away. There's one spring wire that goes to the rear battery terminals as well, so I'll have to unclip that with my little screwdriver. Maybe I could leave it in. This gives me enough access. The screws are falling out, so pay attention to where they fall so I don't lose them. And the on-off switch, cover is the actuator for your finger underneath came off there too, so I got to remember to put that back in at the end. And the optical sensors come loose there, so I can leave that loose, that's fine. And now we can see underneath, these big solder connections here, 1, 2, 3 on that side, 1, 2, 3 on this side. These are the ones we're going to desolder and replace with the switches. So I'm going to go get my soldering iron, warm it up, and be right back. Here we are, back in action. Got my soldering iron here. Switch it on, set it to regular electronics work. You need to be about 350 to 380 degrees Fahrenheit. Oh, sorry, Celsius. What's that? About 700 Fahrenheit. This is about a 60 watt iron. You could probably do this kind of job with a 30 watt soldering iron, just a cheap one from Fry's or JCar or whatever. You need a reasonable sized electronics work tip on it so that you can get enough heat in to melt the solder and desolder it. I've also got my container over here. Get it out. Should have got it out before recording. some solder. This is rosin core 60-30 tin lead. None of this lead-free stuff. Actually, if you can do lead-free, it's better for the environment. It's actually better for people's health. So we let that warm up. We've got the sponge damp but not wet. I'm going to add a reasonable amount of solder to the tip. See, it's quite hot there with the flux. Maybe I'll turn the temperature down slightly. Maybe it's a little too hot. We'll see. I'm going to turn this PCB over and very carefully. I might need my helping hand here too, actually. Make the packaging so difficult on these things. So here's the helping hand, just to hold the PCB up, so you can see what I'm doing with it. And I'm going to pop something else. My other mouse, just on that plastic there, so that it holds that open for you so you can see. I've got my soldering iron nice and hot. I'm going to add a bunch of extra solder to these pads, through-hole pads that the switches connect through, because it makes it a whole lot easier for removing the solder. We're going to take my cheap plastic solder sucker that's really big and has a very strong spring in it. This is called a solder pult. Don't know where it's made. I can't remember when I got it. I got it while I was here in America, and probably off Amazon or something. These are really cheap and plentiful. So we load it. The plunger is spring loaded, and now while we're melting that, I'm going to approach, and that, let's take a look at what that did there. Still a reasonable amount of solder in that joint, so if it proves difficult to suck it all out, I might do something a little bit differently. So let's see. I'll just redo this. Remount the camera a bit higher so you can hopefully see better what's going on. Yeah. Another trick I've done before when servicing these kinds of things, you have to be real careful with all those tiny surface mount components nearby, but it's to do this kind of thing and get all the joints real loose, and then just pull the switch out like that. See, should have done it that way to start with, but we still need to clear out those holes to accept the pins of the replacement switch. So I'm going to touch the soldering iron onto the pads on the top side of the board, melt it all the way through, and then I didn't cock that properly. Now we're cocked again, and that sucks all the solder right out of the hole, ready to accept a new pin of a new switch. Same here. And finally, just a little more flux there. This one. No, didn't quite get it. I moved. Must have moved. It's hard not to move on that one. It's right on the edge of the board. Let me try that one more time here. Why did my light go off? Probably because that's connected to a ground plane or something and needs extra heat. This is why it's easier with a bigger soldering iron to remove things. That extra heat's needed to... Whoops. And yes, we're constantly fighting with little bits of wire. Hopefully I can get this back together again after. That seems to have done it. Now I've got 3 nice holes ready to take a replacement switch. Now I paid attention also to the orientation of the part numbering on the switch and which end the actual actuator is on. That goes towards this end of the mouse. So I'm going to insert that one. Looks like I probably don't need to trim these pins after all. They appear to be just the same length as the ones that I removed. I'm just going to bend them slightly to get this thing to stay flush on the board while I resolder it. So there's the new switch in place. I'm just soldering them like this. Again, paying special care and attention not to get the soldering iron tip close to any of these tiny little components around here. These are all very small, like 0201 sized resistors and capacitors, and if the soldering iron gets anywhere near them, they could disappear into a pool of solder and you'll never see them again and the thing will stop working. So to save time, I'm going to do the second one here, and I'll probably edit this out of the video. We'll see how we go, or speed it up, something like that. Again, just gonna use my old trick of putting the soldering iron on all of those, getting them all nice and hot. Just pulling the whole switch out of the holes. This one's a bit trickier to get my fingers a grip on it. Oh, don't want to melt that plastic. Done. There it is. Got it out. Alright, now let's clean that tip again. Clean those. A little more solder added to them. And once again, get the solder sucker ready to suck. This thing really sucks. Heat from the other side, it was when it's all soft all the way through. That's a neat hole right there. Got a recycling bin right next to me here where I'm ejecting the spent solder. Tip looks like it's glowing red. Oh, it's still way too hot here. working pretty good. Maybe I need just to add some to that to clean it a bit. Right, let's check that out. That one's not empty yet, so I need to do it again. This is also where solder wick can be really helpful, is sucking the solder out by capillary effect. The solder wick just soaks it up like solder braid out of the holes. That's better. That's a nice clean hole now. So let's get another replacement switch here. Here it is. And again, printing's going to go on this side with the actuator lever towards the front of the mouse. So it's going in there. Oh, I can't get that in the middle hole. Seems like it's still got a lot of solder in it. Let me just do that one more time. One more time. We'd say in Australia, one more time for the dummies. Okay, let's try again. Oops. Did that work? It appears to have worked. So here we are, I'm putting the new switch in. Yes, and this time it goes in snug. Now I shall solder the new switch in. Notice I'm starting by wetting the solder to the pin and then adding more as I bring the soldering iron back towards the pad on the printed circuit board. And as soon as it touches the printed circuit board sucks it on, and we get a really nice, I can't get that to focus. Let's bring it back there. It's hard to see here with this, can't get too close with the webcam, but we get a really nice fillet on that joint. So now all that remains is to put this whole thing back together, and hopefully it works just fine. I'll turn the soldering iron off, no sense in wasting energy. Alright, now in order. Switch actuator for the on-off switch, and the on-off switch is in the off position. The optical sensor for the mouse goes on. That whole board goes down and is sitting snug. Now I've got the screws that hold that down, so I'll put them in. Here. They're not magnetic, and that makes it a bit tricky. It would be nice to have screws that stick to the end of the screwdriver for this, but okay. So we're doing that one. So the board's pretty firmly in place now. One more screw back here under the sensor wire. Just tuck that out of the way temporarily. No, that one doesn't go. Must be the wrong length. Let's see. Why are they going in? Something not right there. All these screws are the same, so oh no, those just hold the sensor on, so they can go separately. This is where a little bit of fingernail comes in handy. Hold the screw on the end, get it into the hole. Now I can feel it bite into the clear plastic on the back side of the optical sensor. Now the next one should go in no problem because the optical sensor is fixed by that first screw. And yes, I feel it bite in. So those are done. Now that whole thing needs to be held down by one screw over here. Do that again. This one right here. That's nice and firm, and the last two screws to hold this in as a full assembly. I have to move this optical sensor white cable back to the middle so it's not in the way. Check that ribbon cable, that seems to be going okay. Now, this is the tricky part. Not dropping the screws and losing them. So I've got a hole in there and a hole in here, in this side. Sometimes it might be easier to let the screw balance in the screwdriver and poke it up into its hole there. Oh, there it goes. Losing it already. Let's do the other one and then I'll get that. Maybe sideways is the ticket. this, nice and tight. Sideways is the ticket. Let's find that other missing one. Luckily it's easy for me to hear where these things go. Sideways this way. Yeah, so that one's nice and tight. All screws back in, new switches in. They feel good. Now let's get this wheel situated. Wheel appears to be a pretty simple affair. I think that spring goes down on this little black post right in here. Getting it to sit on the black post will be a bit of a challenge. Maybe I need to loosen these battery compartment screws and lift that up. But they'll stay in their holes. So that can go up. That can go down there, and then there it is. It's in the right spot. And these can tighten up again. It's flipping its switch, scrolling its wheel, its optical sensor. Alright, final assembly. The front end first, back end goes up there. Last screw, back where we started, in the receiver holder compartment. And we're back together. So now all that remains is to try it. Hopefully these batteries are still good. I believe they were fresh. And I'll turn it on. Let's see if they are fresh. The green light comes on, so they're fresh batteries. So now all I've got to do, plug that receiver into my USB port back here. And the computer is detecting it. It's installing the driver. There we have it, and it's working. And the button clicks. It's functioning again. I'm very happy. It's a good mouse. It's got a good feel to it.